The search for life beyond Earth is one of the most important questions that scientists are trying to answer. The discovery of Kepler 186 system is a major step forward in this quest. The system itself comprises of 5 known planets, Kepler 186b, c, d, Ea, and F, orbiting a host star named Kepler 186. Let's turn our attention to Kepler 186, an M-class red dwarf star, located approximately 582 light-years away. Compared to our Sun, Kepler 186 is about half the diameter and half the mass, resulting in a mere 5% of the Sun's luminosity. Additionally, this star exhibits lower metallicity than our Sun. In astronomy, metals refer to elements beyond hydrogen and helium, those with atomic numbers greater than 2, since hydrogen and helium make up the vast majority of the visible universe. It is logical to categorize other elements as metals. Metallicity plays a crucial role in understanding stars and their planetary systems because the composition of the gas and dust cloud from which they form influences the formation and characteristics of planets. Stars with low metallicity are less likely to harbor large gaseous planets like Jupiter and Saturn, but have a higher probability of hosting rocky worlds akin to our own. In the case of Kepler 186, we have discovered 5 planets orbiting this star, all of which appear to be rocky in nature. Let's take a closer look at each planet, starting with the innermost and moving outward. The inner trio consists of Kepler 186b, c, and d. These planets orbit in close proximity to the star. Kepler 186b has the shortest distance from the star, at just 0.38 astronomical units, or 5.7 million kilometers, completing an orbit in a mere 3 days and 21 hours. Planet C is slightly farther, orbiting at 0.57 astronomical units, or 8.55 million kilometers, with an orbital period of 7¼ days. Lastly, Planet D lies at a distance of 0.86 astronomical units, or 12.9 million kilometers, taking approximately 13 days and 8 hours to complete an orbit. In terms of size, all 3 planets are slightly larger than Earth. Kepler 186b is the smallest, only 8% larger than Earth, while Planet C is about a quarter larger, and Planet D takes the title of the largest among the 3, being 39% larger. All of these planets are likely tidally locked, with one side permanently facing the star, enduring its scorching heat, while the opposite side remains in perpetual darkness and freezing temperatures. Due to their close proximity to the star, it is unlikely that these planets possess substantial atmospheres, as the intense solar radiation would strip away any gases, leaving them exposed to the vacuum of space. If we were to stand on any of these planets and gaze towards the star, it would dominate the sky, appearing significantly larger than the Sun does from Earth. On Earth, a full rotation from north to south covers 360 degrees, while the apparent size of our Sun spans only half a degree. However, on these inner planets, the star would occupy a much larger portion of the sky. Moving outward, we arrive at Kepler 186e, which orbits at a distance of 0.12 astronomical units, or approximately 18 million kilometers, completing one revolution around the star in about 22½ days. Although it lies farther from the star than the inner planets, Kepler 186e remains within the habitable zone. With a radius approximately 1/3 larger than Earth and a mass roughly 2¼ times greater, this planet boasts an equilibrium temperature of 323 Kelvin, around 50 degrees Celsius or 122 degrees Fahrenheit. If it possesses an atmosphere, it might resemble Venus in our own solar system. Finally, we reach our main point of interest, Kepler 186f. This planet orbits at a distance of 0.43 astronomical units, or roughly 64.5 million kilometers, slightly beyond the orbit of Mercury in our solar system. While Kepler 186f resides within the habitable zone, it hugs the outer edge, much farther from the star than Earth is from the habitable zone of our Sun. Kepler 186f measures 17% larger than Earth in terms of size and boasts a mass 1.4 times that of our planet. Consequently, it exhibits a surface gravity approximately 17% higher than Earth's. Standing on the surface of Kepler 186f, One would notice the additional gravitational pull, but it would not be unbearable. A person weighing 75 kilograms or 165 pounds would experience an extra 12 kilograms or 28 pounds of weight. In terms of temperature, the equilibrium temperature of Kepler 186f, without accounting for any atmospheric effects, would be 188 Kelvin, equivalent to 85 degrees Celsius or 121 degrees Fahrenheit. This is approximately 20 degrees Celsius or 68 degrees Fahrenheit colder than the equilibrium temperature of Mars. However, it's worth noting that Mars has a sparse atmosphere, which means its equilibrium temperature closely matches its actual temperature. On the other hand, due to Kepler 186f's larger size, it is possible that the planet possesses a denser atmosphere, which could significantly affect its actual temperature. It would be a missed opportunity to travel all this way without imagining what it might be like on the surface of Kepler 186f. Being within the habitable zone simply means that liquid water could exist on the planet's surface. As we envision the scene from above, we see vast seas and oceans adorned with substantial polar ice caps. Landing near one of these bodies of water, we observe that the light on Kepler 186f is dimmer compared to Earth. Even at midday, the illumination resembles Earth's twilight. Furthermore, the light on this planet exhibits an orange hue. Let's indulge our imagination and consider the possibility of life existing on Kepler 186f, though we must keep our speculations relatively simple given the limits of our knowledge. Here, we visualize a photosynthetic organism. On Earth, plants' leaves are green, reflecting green light and absorbing other wavelengths. However, on Kepler 186f, the leaves of these hypothetical plants are black, maximizing their absorption of the limited available light and maximizing energy production. The existence of life on other planets is a tantalizing notion, and if it indeed exists, it is likely to be stranger than our imaginations can conceive. While natural selection and evolution are universal principles governing the development of life, the idea that extraterrestrial life would resemble Earth's life forms is mere fantasy. Life as we understand it, based on carbon chemistry and reliant on water, may share some tenuous similarities with potential alien life. Nonetheless, the details are bound to be vastly different. Now, it is time to return to our space and time machine for the relatively short journey back to our home planet. Until next time, thank you for accompanying us on this cosmic expedition.